So hello and welcome back to our C++ tutorial series. I am Akshat Jain and I am a software development engineer. In our previous video, we've explored this standard template library in C++ and we learned about vectors, sets and hash maps. In this video, we'll dive deeper into STL algorithms and we'll cover three important aspects: sorting, searching and iterating. So let's get started. Okay, so sorting algorithms are essentially for arranging elements in specific order. The STL provides efficient sorting algorithms that can be used with various containers. So let's explore the sort algorithm. So let's write some code to demonstrate the usage of sort algorithm in an STL. Okay, so in this example, we'll use the vector container from the STL and the sorts its element in ascending order. So let's get started by writing some code. Okay, so since we know that to include vectors, we need a specific library called #include_vector, and to include all the algorithms, be it sorting, searching, anything, we have to include a header file called algorithm. Now, first of all, the first thing is, since we needed a vector over here, we have to declare a vector. Let's declare a vector int and name it as nums. Okay. Let's take input first. Let's take input from the user. I will write for int I equals to 0. Okay, let's take a number n. Okay, let's take a number n. For int n, we'll take c in as n. We'll write c out, enter n. Okay, n will be the size. Now we'll write for int I equals to 0, I less than n, I plus plus. Okay, I plus plus. What I will do is I will take an input int x, c in x, and I will push that x into the vector. So I will write nums dot push back x. So this will put all the elements like 1, 2, 3 and so on. Okay, now let's print that elements first. Okay, before sorting, let's print for, I can use auto operator also. Let's use auto operator for auto it. In what? In nums, I will write c out it space and I will print c out and del over here. Okay, so let's see, our code is running fine till now or not. Okay, let's enter n. Let me zoom it here. Okay, let's enter 5, 6, 3, 6, 1, 9. Let's hit enter. So it is printing 6, 3, 6, 1, 9. So our elements are coming in an order like we have inputted. Okay, now let's sort it. So there are various sorting algorithms like bubble sort or selection sort or insertion sort, merge sort, but the concept of writing them is very big. Okay, you have to give some time by writing code. You have to understand everything. If you are writing the merge code, you have merge sort code, you have to write the merge functions and you have to write the sorting functions. So in C++, this simple function called sort. That's it. It takes some parameters. Okay, it will take some parameters and it will sort the entire array based on what you have decided to, like ascending or descending. Let's print ascending first. Okay, so how we can do is we'll write sort. Okay, now what is our vector's name? Nums. We'll write begin, comma, we'll write nums dot end. Okay, so from starting to end, we have given the starting address and we have given the last index or last address of the element. Now between those, okay, we have to perform sorting operation. Now let's see, after sorting, it is printing fine or not. Okay, it is after sorting. Let's run it one more time. Let's take some input again. Let's take 5, 90, 34, 32 I have taken, 12, minus 9 and 7. Let's see. So before sorting was 90, 32, 12, 9, minus 9 and 7. After sorting, it is very clear: minus 9, 7, 12, 32 and 90. So this is how they are printing in ascending order. Now if I have to print in descending order, what I can write is r begin and r end. R basically means reverse begin and reverse end. Now let's see, it is printing correct or not. Okay, so I have written 5, Okay, let's print 1, 2, 3, 4, 5. So it is printing 5, 4, 3, 2, 1 after sorting. Have you seen it? So this is how you sort ascending or descending in vector using sort functions. Okay. So in this program we included the vector and algorithm header files from the STL. We created a vector container called nums and we initialize it with some numbers, okay, by taking the input from the user. Then we use a sort algorithm from the STL library to sort the elements in ascending and descending order both. Finally, we displayed the original and sorted numbers using the range based loops, okay, like for int, for auto, for int, okay. After the execution of program, we can see that both the numbers, like we have to see that original and sorted numbers are displaying. So we can say that the sorting algorithms work very fine with STL. Okay. Now, searching algorithms. Searching algorithms allow us to find specific elements or perform certain conditions on elements with a container. Some example, I have given an array 1, 2, 3, 4, 5. I have to find is 3 present in array or not. So what I can do, I can perform linear search or binary search by writing some piece of code over there. But in STL, there is a function called find which will return if the number is present or not. Okay. So STL provides efficient searching algorithms that can be used with various containers. Okay. So let's explore the find algorithm. So let's expand our example to demonstrate the usage of find algorithm in STL. Okay. So in this modified version, we'll use the vector container again and search for a specific element. So let's get started. So I've written the code over here. I have taken numbers, okay, 52197 and I have a target 9. Okay. So I have written, you have to understand it, what I have written. I have written auto IT, find, nums.begin, nums.end and target. So the parameters are starting range to ending range. Okay, it is a range and a target. What I have to find inside those range using the find. Okay. Now what is auto? Why I have written auto over here? Because it will return something which we don't know which type of data type they sent or not. So that's why we have written auto to automatically check the data type. Okay, so it will check. Okay. Now basically it sends the address. So we don't know address is coming in which type of data type. That's why we written auto. Okay. Now if it is not equals to numbers.end, what does it means? Means it does not reaches the end point. Okay, in the middle it found the target, so that's why it is saying that it does not reaches the end, therefore we can say the target found at index this. Okay, and same for what is distance? Distance basically calculates the distance between the starting point and the point that meet, and it will return the index over here. Okay, let's understand by running it. So we can say the target 9 found at 2. Yes, it was at 2. Okay. Suppose I have written 90 over here. So 90 is not present. Then see, it is printing target 90 not found. So we have explored the find function and the distance function. Okay. So in this updated program, we use the find algorithm from the STL to search the specific elements in the numbers vector. Okay. We store the iterator returned by find in the it variable. If the target element is found, we display the index using the distance function. Otherwise, we display a message that simply that target is not found. Okay. So this was about sorting and searching. Now let's move forward with iterating. Iterating is a common operation that allows us to access and manipulate elements in a container. The STL provides several algorithms that can be used for iterating over containers. Let's explore for each algorithm. This is the most easy algorithm and you will find it very useful when you start coding, when you start competitive programming or when you start working on DSA. Okay, so let's expand our example to demonstrate the usage of for each in algorithms in STL. So in this modified algorithm, we will again use the vector container once again and perform an operation on each element. So let's get started over here. So what we have done in this code is we have again created a vector numbers and we have printed the original number first. Okay. Now the for each means for each elements we have to perform a specific function. A function is what? We have written a void square. It will calculate the square of an element. Okay. So I have written for each number between begin to end, the range. Okay, from starting to end, I have to perform the square operation. The square operation is taking a number over here. We are taking a number. I have written the ampersand because it is taking by number by address. Okay, and I am computing the square over here, nums into nums into nums equals to nums into nums, so it is computing square, and I'm not returning anything because I've changed it in directly to the address. So after performing this, we have returned the squared numbers. Let's run this code and see how it is printing. So it is printing like original numbers 52917 and the squared numbers are 25, 4, 81, 1 and 49. Let's if I changes something like 0 and here I will write 11. Let's run it one more time. 5, 25, 2, 4, 0, 0, 11, 121 and 7, 149. Okay, so in this updated program we defined the function called square that squares the value of a given number by modifying it. Okay, we use the for each algorithm from the STL to apply the operation on each element in the numbers vector. Finally, we displayed the result. So after executing the program, we'll observe the original numbers followed by the square value. So we have understood everything. I hope you have understood everything. So excellent. In this video, we explored important STL algorithms in C++. We covered sorting, searching and iterating using the sort, find and for each functions. Okay. These algorithms provide powerful tools for manipulating containers efficiently. In the next video, that will be our final video, I will be discussing about some advanced topics in C++ and some most important and easy questions you have to solve to gain the knowledge of C++ so you can understand the syntaxes of everything for if, else, for loop, array, strings, everything. So wait for the next video. Till then, stay tuned and happy coding. Bye bye.